All right, guys, let's try this. So when we do this, first thing we're going to do is take our highlighter or our marker, and we're going to mark off this boundary right here. So I'm going to go on my graph, and I'm going to go to -2, and I'm going to make sure I identify clearly where that boundary is. Okay? And then we can do this a couple different ways. So I know I showed 6 spell a way that's different than what I'm going to show you. First of all, this is not squared on yours. Okay. So first thing that we're going to do is, now that we know that it's going to switch over from one to the next, this is going to be our first one, which will be on this side, the left side, and this guy right here will be over on the right side of the graph. One thing to know for sure is that no matter what, if the first graph says it's x plus 5, then that's essentially like thinking about that line. If I go to 5 on my y-axis and I graph that, and I have a slope of up 1 over 1 or down and right, basically it is always going to be this line, okay? However, you can't graph the entire line because it's saying that this part over here on the right side doesn't belong over there. So essentially, you could graph the entire line and then just erase the right side, or graph the entire second line and just erase the left side. However, we can do it a couple different ways, okay? So that was one strategy. I'm going to show you a different strategy. In the case of the couple that we did in class, I showed you that way, okay? But here's a different way that I'm going to show you, since I have a little bit more time, and I'll show it to you on like 2 examples. You know that the slope of the first line is going to be 1, and you know that it's going to change over at the boundary. So one thing you can do is you can plug in or substitute whatever that boundary value is into both equations. So you're going to plug -2 for your x into both. That will give you an equation, or sorry, that'll give you an ordered pair of where each one sits in. So if I use this first one, I'll do this down here in purple. If I plug -2 into this equation, I get f of -2. That's going to give me the value of 3. So I have an ordered pair, -2, 3. And I can go plot that, and it's going to be right on the boundary line. 1, 2, 3. And this dot is going to be open, because this one right here says that it's open. Okay? From there, you can then apply your slope. So another strategy is to apply your slope after you plug in your boundary point. So from here now, that point -2, 3, I'm going to go up 1 over 1, which sends me into the wrong territory. So I would go down 1, left 1, down 1, left 1, down 1, left 1, till I get a few points lined up, and then I have that one graphed. For the second one, I'm going to do the same thing. I'm going to plug in -2 into this one, and I'm going to see where that one gets me on the boundary line. So I know that at -2, that one's going to give me a value of 1. So I have an ordered pair at -2, 1. This one, however, is going to be a closed dot because the -2 is included. From there, I can also apply my slope. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, until I get a few points that way. So that's an alternative way to do it, okay? For our domain, you're going to basically combine the 2 domains together to make the entire domain. So these are individual domains for the individual 1 and 2 graphs. If I put them together, I get everything -infinity to infinity. The range, on the other hand, if I look bottom to top, the bottom of my graph, I'm going to erase this, is here, but it has an arrow attached to it. So that means it's going to go down to -infinity, and on the upside, it's going to go up to +infinity. Okay? For these guys right here, I'm not going to go over those again. Refer to your notes from yesterday if you need to see those again. Okay, so check those out on there if you need to see those again. All right, let's try this one. Again, take your marker or your highlighter, go to your boundary, which is at +1. Create your graph, okay? So that's my boundary point right there. Then you're going to plug in your boundary value. Okay, so this is 1 over here. 2 is on the right side of that boundary. So graph number 2, and obviously we don't have that. Graph number 1. So I'm going to plug in 1 and see what I get. So 2 times 1 is 2 plus 1 gives me a value of 3. So then I go plug that in or plot that point 1, 3 on my boundary, and that one's the closed dot. And then I apply my slope. So instead of going up to right 1, because that's sending me into the purple territory, I want to go down to left 1, which is the equivalent to a positive slope. Down to right 1 until I get several dots lined up. Maybe I could draw a straight line. And I get that one. Same idea. This is going to be an open dot, however. So I'm going to take my 1, and I'm going to do 1 plus 3 here, and that's going to give me a value of 4. So I get 1, 4 is an open dot, and then I'm going to apply the slope on that one. When I join forces, again, for my domain, I get everything. If 1 is everything less than 1 and 1 is everything greater than 1, oh crap, I did these on the wrong side. Look at this. How about the fact that these two right here are backwards? They don't go in the right order. I have these on the wrong side. So let's kind of erase this. The point is right. However, these are on the wrong side. Oops. Let's start that over. Let's fix this. Okay. So this is actually territory 1 because this is the x greater than or equal to 1 side. I didn't catch that. Normally they are in order. And this is graph 2 because this is the x less than 1 side. That's dumb. Okay, so this one's going to have my slope that's a positive 1 over here with purple. And this one's going to have the slope positive. Struggle bus in here, people. This one's going to go up 2 over 1, up 2 over 1. So this is going to have this steeper slope. Let me fix my open dot. Okay, that's better. Glad we noticed that. However, going back here, your domain and range are both negative infinity to infinity. Okay, we'll do one more together. Let's find our boundary, plot that guy. So our boundary is at 2. So I'm going to go to 2, put that boundary. Then I'm going to plug 2 in. Let's see if this one's consecutive. So yes, it's in the right order. So this is definitely the less than or equal to 2 side. And this is definitely the greater than 2 side. So we're going to plug 2 into both of these and see what we get as our output. So 2 times negative 2 is negative 4. Negative 4 plus 1 gives me a value of negative 3. So 2, and then I get a point at negative 3, making a closed dot. From there, your slope is negative 2. So you would go up 2, left 1, up 2, left 1. And what you notice is right there, there's your original y-intercept, this plus 1 number here. Okay, so you definitely would be able to use that still. Okay, and on this side, you're going to plot 2, 10 minus 4 gives you 6. So you're going to go to 2, 6. That's going to give you an open dot, and your slope is up 5 over 1. I certainly don't have room for that, so I'm just going to cheat a little bit and draw an arrow. Okay, if I wanted to, I could come down 1, 2, 3, 4, 5 over 1. It would have been lined up here just in case you were trying to get a nice straight line. Okay, the difference on this one is your domain and range. Your domain is still everything. When you combine this, you still get negative infinity to infinity. But your range, on the other hand, if you look, you never drop below this line right here. So we have to take that into consideration, that y value of negative 3 is the lowest it ever goes. So it's going to go from negative 3. Since both of your graphs go upward, then everything's going to be above that. Okay? So I hope those three help. If you want to see how to write an equation, I'm just jumping to, let's go to this one, for instance, number 10. You have 3 sections to this graph. So if we look, that's the first. Here we have the second one, and then we have the third one. Unlike that silly one that I messed up, make them go in order. So name your function, f of x, g of x, p, q, whatever you want. Find your boundaries. So my boundaries here are going to be at -2, +2. So I'm going to say for the first one, that's for all x's less than. Because this is right on the boundary, you can't really tell which one's including the -2. We'll just throw it into that one. The second one is going to be from -2. I can't include it here, but I can include the +2 on this one. And then the third one is going to be for all my x's bigger than +2. Okay? Now the second one is a nice horizontal line right there. So at 1, 2, 3, 4, so automatically it has a value of 4. There's 0 slope. So I don't, that section, that second piece is done. Okay? But I have to go up here to this one, and I can do one of two things. I'm going to take that ordered pair, that's at -2, 1, 2, 3, 4, and I'm going to use it to write myself a slope-intercept equation. So I'm going to do y - 4 equals, we can also count the slope. The slope is up 3 over 1, so I know the slope is 3, and then do x minus -2. And we can then figure out our equation of the line that way. So if I add 4, I get y equals 3x plus 10. So this one is going to have the equation 3x plus 10. Well, you can do one of two things. Since graph 1 and graph 3 are symmetric about the y-axis, you could, in theory, just say, well, I know this is the same thing, but it has negative slope. Or, likewise, you could say, okay, I know that's the point 2, 4, and do the same thing that we just did. And you would do y minus 4 equals -3 is your slope, x minus 2. Distribute that -3. And then you get the equation y equals -3x plus 10. Okay? And then your equation is written. So this is the equation. Now, for graphs like this one right here, you have 3 sections. They have non-overlapping stops and starts. So those are going to be separate. This piece right here should be pretty easy for you to find because it has a y-intercept that's visible and a slope that's easy to count. This one right here, you could extend the graph and just count to figure out where it's going to cross the y-axis. Same thing for this one. Don't make it harder than it is. Okay? I hope those helped.